Today, anyone can use ChatGPT, DeepSeek, or LLaMA to generate code for their embedded devices. But can you get an LLM to execute code on the microcontroller in real time, responding instantly as you describe what you need? Let's look at a quick demo. We have a Telegram bot that allows us to send voice commands to our AI agent.
Create an LED chaser.
Our voice command is converted to code and executed in real time.
Move the servo to 180 degrees.
MicroPython allows the Pico to run freshly generated code without requiring a full firmware reflash.
Create a rainbow pattern on the LEDs. Turn off all the LEDs and make the servo move to 75 degrees.
We will use open source models via Groq for this project. Now, let us deep dive to understand how everything works. We first create a bun server that manages the Telegram bot as well as interacts with the LLM services. The server receives voice messages from users through Telegram, processes them by converting OGG audio to MP3, and then sends them to the Groq API for transcription. After receiving the transcribed text, our code generation agent prompts the LLaMA model to generate appropriate MicroPython code for LED patterns or servo control. The generated code is made available to the Pico through simple API endpoints. The Pico regularly polls our server to check for new code instructions and when a new version is detected. It fetches the freshly generated code and executes it immediately. This creates a seamless pipeline from voice input to physical peripheral output, with the bun server orchestrating the entire process while maintaining security through authorized chat ID verification. Let us look at the Telegram bot code more closely. Bots are special Telegram accounts designed to handle messages automatically. Use the Botfather Telegram bot to create your own bot and get the required bot token first. We start by importing the required packages. We use the telegraph.js library to manage our Telegram bot. Next, we set up all the required environment variables and initialize the bot, Groq client and code manager and agent objects. More on them later. The bot has a start command that logs the user's chat ID, which is useful for authorization, and sends a welcome message explaining how to use the bot. Every time the user sends a voice message, we want the bot to perform certain tasks. To do this, we set up the onVoiceMessage handler function. The handler first checks if the voice message is coming from an authorized chat ID, and then checks for the duration of the message. This is important to ensure safety. Next, it downloads the audio file from the Telegram servers and converts them to MP3 format required by the LLM for transcription. We use the Whisper Large Turbo model for transcription of the audio and then pass the transcribed text to the code agent to generate the required MicroPython code as instructed by the user. The generated code is then formatted and sent to the Telegram bot to show to the user. Along with controlling the Telegram bot, the bun code also creates a simple HTTP server on port 3000 that exposes to endpoints. These endpoints are used by the Raspberry Pi Pico to check for new code and download it when available. We also have a code manager class that serves as a simple in-memory storage system that maintains the current code version number and stores the most recently generated code, as well as provides methods to update and retrieve the code. Additionally, we also have two helper functions that download the audio message sent by the user via Telegram and convert the same to MP3 format. Now, let's look at how the code generation agent actually works. This class serves as the AI-powered bridge between natural language voice commands and executable MicroPython code. This agent uses the Groq API to transform user requests into precisely formatted code for controlling the LEDs and servo on a Raspberry Pi Pico. We craft our prompt for the LLM to ensure it effectively incorporates the user's voice command, specifies the existing code running on the Pico, and outlines key constraints. such as limiting iterations to 20 and avoiding infinite loops. Additionally, the prompt provides clear instructions on when to control the servo, and includes template examples to guide the expected code structure. The method then calls the Groq API, setting the AI's role as a MicroPython assistant and sending the constructed prompt. It uses the LLaMA model with a low temperature for consistency, a 1024 token limit for completeness, and no streaming for simpler response handling. Finally, let us look at the MicroPython code for the Raspberry Pi Pico. This program is relatively simple. We first import the required modules and provide the Wi-Fi credentials. We then have a few helper functions that help control the peripherals, and a function to check the latest version of the code on the bun server. The crucial part of fetching the latest code and executing it in a new namespace using the exec function is handled by the fetch and execute code function. The main function of the code simply keeps polling the bun server for any update in the code version, and if a new version is found, it is executed.
Create a rainbow pattern on the LEDs.
Run both the bun server and the MicroPython code together and experiment with what all LLMs can do. We hope that you liked the project. Feel free to ask any questions in the comments below. The link to the complete code is in the description.